Okay, let's get started. We left on page 64. Let's take a look. Let's get going. Welcome back. Okay, so let's see. I think this is where we were at. Evaluate. Yep. And next, let's read over here. Okay. All right. The preceding example uses var to declare only simple variables, but you can also use var to declare an array. For example, var my array no, int 10. This is valid. All right. Let's see. Okay, I need to do something quickly here. Let's do this. Okay, and make it okay, and that should be fine. But and that will be good. Are we? Okay, well, still a little off, but that will have to do. Yeah, still a little off, but that'll have to do. Oh, excuse me. Okay, so here we go. Notice neither var nor my array has brackets. Instead, the type of my array is inferred by the int. Furthermore, you cannot use brackets on the left side of a var declaration. Okay. Thus, well, on the side of a var, on the left side of a var declaration. Thus, both of these, I think that what it should have said is on the left side of an assignment statement. Is what it should have said. Thus, both of these declarations are invalid. And here we got the declarations and why they are invalid. Okay. Because they're on the left side of the assignment statement. Okay, because this is a declaration, but it's also an assignment statement. Technically, anyway. In the first line, an attempt is made to bracket var. In the second, an attempt is made to bracket my array. In both cases, the use of the bracket is wrong because the type is inferred from the type of the initializer. It is important to emphasize that var can be used to declare a variable only when that variable is initialized. Okay. Okay. For example, the following statement is incorrect. Var counter, wrong, initializer required. Right, because it has nothing to infer from. Also remember that var can be used only to declare local variables. It cannot be used when declaring instance variables, parameters, or return types, for example. Although the preceding discussion and examples have introduced the basics of local variable type inference, they haven't shown you its full power. As you will see in Chapter 7, local variable type inference is especially effective in shortening declarations that involve long class names. It can also be used with generic types. Ooh, nice. In a try with resources statement, see Chapter 13, and with a for loop, see Chapter 5. Oh, wow, I never seen those. See, this is why I thought it would be a good idea to write this book. Because I did not remember seeing that in the course, using var with a for loop. That is a very interesting use case. So I can't wait to see that when we get to Chapter 5. All right, so let's see. Some var restrictions. Okay. So, in addition to those mentioned in the preceding discussion, several other restrictions apply to the use of var. Only one variable can be declared at a time. A variable cannot use null as an initializer, And the variable being declared cannot be used by the initializer expression. That I have to see to better understand. Okay. Okay, so let's see. Although you can declare an array type using var, you cannot use var with an array initializer. Oh, I see. Okay. That's like one of the exceptions. Very cool. That looks. It almost looks like. It's easy to think that you can do that when you can do something like this, you know. Like, well, not like that. Excuse me, because that has a bracket on the left side. One like this. And you can do something like this, right? But you're not initializing it, you know, because you're only creating the object in this case with the new int 10. That's creating an object. That's it. It's not initialized to the, you know, to the values that you want in it, except that it has default values, of course. Okay. So okay. So new intent. This is valid because that's a declaration, but this is not valid. My array, because that's initializing the actual object array with values. So that can be understood. Okay. All right. So next, let's scroll up a little bit. As mentioned earlier, var cannot be used as the name of a class. It also cannot be used as the name of the other reference types, including an interface. Okay. Include an interface, enumeration, or annotation, or as the name of a generic type parameter, all of which are described later in this book. Here are two other restrictions that relate to Java features described in subsequent chapters, but mentioned here in the interest of completeness. Local variable type inference cannot be used to declare the exception type called by a catch statement. Oh, of course, you know, like when you say like catch E and then you give it a definition. So you're gonna say like catch var, I think is what he's going to explain. Also, neither lambda expressions nor method references can be used as initializers. Oh, okay. Okay. Now, at the time of this writing, a number of readers of this book will be using Java environments that don't support local variable type inference, so that as many of the code examples as possible will compile and run for all readers. Local variable type inference will not be used by most of the programs in the remainder of this edition of the book. Using the full declaration syntax also makes it clear at a glance what type of variable is being created, which is important for the example code. Of course, going forward, you should consider the use of local variable type inference where appropriate in your own code. Of course. Alright. So, a few words about strings. Okay. As you may have noticed in the preceding discussion of data types and arrays, there has been no mention of strings or a string data type. This is not because Java does not support such a type. It does. It's just that Java's string type, called string, is not a primitive type because it's an object. Nor is it simply an array of characters. Rather, a string defines an object. There you go. And a full description of it requires an understanding of several object-related features. As such, it will be covered later in this book. Other objects are described after other objects are described. However, so that you can use simple strings in simple programs, the following brief introduction is in order. Of course, who doesn't like to do with strings? Okay, give me just a second. Drinking my Red Bull. And let's get back to reading. Alright, so here, I'm sorry, sometimes when I press my shortcut, this thing resets. Okay. And for some reason, now the system is slow and the page is not. Okay. Excuse me a second, guys. Okay. Okay, here we go. Okay, I apologize. So let's get back to this here. Okay, let's make this a little larger. It's probably not a good idea. Okay, so let's just do 250. There we go. 250 is good enough. That's good. Okay. Okay. Oh my God, why do I keep doing this? I'm sorry. Keep messing up. Let me fix this. And it's not really that I'm messing up, it's that the system is like slow and it's not catching up to my commands like on time. So it's like all over the place. Okay, so now we can be back. Okay. Okay. And here we are. String, and now it looks like it's a little too big for the screen, so let me there we go. Alright, so that's better. The string type is used to declare string variables. You can also declare arrays of strings. Okay. This must be working here. Okay, let's try now. Much better. Okay, so the string type is used to declare string variables. You can also declare arrays of string. A quoted string constant can be assigned to a string variable. A variable of type string can be assigned to another variable of type string. You can also use an object of type string as an argument to print line. Very nice. Okay, so for example, consider the following statement. You know, this is really important because there are, in fact, objects where you're going to have to modify the print statement and override it, because otherwise, when you print, what you'll get as a result, as an output, is the address of the object and not the actual content of the object. So this is really interesting stuff right here. Okay. Alright, so back. Okay, so file example, string, this is test, this is the printout, print, this is a test, okay? Alright, so we are actually going to do this. We're going to do this, okay? We are going to do this. Okay, and I apologize, I just got to pause the video for a moment. And I will be right back. Okay, we are back. Alright, let's get back to reading. Actually, the shell here. So we're gonna do the code here. This is what the J shell is good for. str. This is a test. Okay. And then Actually, should have started out with a bracket. Well, we could still do it like this. We could run both codes. We could go like this, okay? And then I can do. Send that out. That print line. str. And it will print it. So that's what that is. There are instances where that will not work, because if you put an object in there, strings are the exceptions that always work, but if you put other kinds of objects, as far as I know, they always work. But if you put another type of object, it will print the address and not the actual value, not the actual content of the object in memory. So it's very important to test this out. Okay, let's get back to read. Okay, so here str is an object of type string. It is assigned a string. This is a test. This string is displayed by the printline statement. As you will see later, string objects have many special features and attributes that make them quite powerful and easy to use. However, for the next few chapters, you will be using them only in their simplest form. Alright, next page. Okay, page intentionally left blank. Alright, let's see what's next. And chapter 4, okay. We are at the chapter of operators. Okay, well let's just go back to chapter 3 so I can pull up chapter 4 a little further up. Okay. Here we go. Okay, so first, looks like there it is. There's a system up. Okay. Sorry. Let's try that again. There we go. Okay, so Java provides a rich operator environment. Most of its operators. All right. Okay, you know what? I'm sorry. We're gonna have to do something here. We're gonna have to just move it like this. There we go. Much better. I'm not sure. I think it's part of one of the effects that I put on it. Okay. So most of its operators can be divided into the following 4 groups: arithmetic, bitwise, relational, and logical. Java also defines some additional operators that handle certain special situations. This chapter describes all of Java's operators except for the type comparison operator instance of, which is examined in chapter 13, and the arrow operator, which is described in chapter 13. That's because the arrow is part of the lambda expressions. Okay. And the instance of, basically, I believe it compares objects. Like it says, is this an instance of this object? I think that's the reason why it doesn't want to. He's not going to cover that. So he's probably going to talk about that when he talks about objects later. Okay, so let's start with the arithmetic operators. Okay. Okay, so arithmetic operators. There we go. Arithmetic operators are used in mathematical expressions in the same way that they are used in algebra. The following table lists the arithmetic operators. Here we go. Addition, also unary plus. Subtraction, also unary minus. Multiplication, division, modulus, increment, addition, assignment. Oh, excuse me. Subtraction, assignment. Multiplication, assignment. Division, assignment. Modulus, assignment. Decrement. So basically, the addition, subtraction, multiplication, and division assignment, what they do is they do the subtraction and then assign the result. They do the operation and then they assign the result. That's what that is. Pretty stuff. But we'll read to them anyway. All right. So what we're gonna do is we're gonna pause the video now because I think we're just about 25 minutes if I'm correct. I didn't notice the count, and so it's best to pause so that we don't overextend the a couple of times already. So we'll continue at page 67 and we'll get back to it. Thank you.